Hi everyone. Let's define the matrix and know the difference between different type of matrices and also make the basic operation like addition, subtraction, and multiplication. A matrix is a single. The plural for this one is the matrices. So you have more than one matrix. You can say matrices. This is a matrix. It's not a table. It is, they call it array, right? So array means you have rows and columns. And we call the matrices by capital letter A, B, A capital, B capital. So we have two rows here and three columns. So if you multiply 2 by 3, you have 6 elements here. So each one of these is an element, right? Okay. Okay. So this one, 2 rows by 3 columns. This is how to write the size of the matrices, or you call it the degree of the matrices, right? But B had first 4 rows written to the left, and column we have 3 columns, so 4 by 3, it means you have 12 elements inside, right? Okay. Each number in the matrix is an element, right? So how many elements are there in A? In A, I said it is 2 by 3, so it is 6 elements. B, 4 rows by 3 columns, so it means you have 12 elements. Okay. This is, they call it the size, some people they call it the degree, and some people they call it dimension. N, okay? So you write M by N, it means M rows and N columns. Okay? This is exactly what we have done. A has a size 2 by 3, 2 rows. This is a number of rows. This is the number of columns. Okay? It's exactly be the same, right? Okay. Now, if you have this one, this is 3 by 3. So the number of rows equal to the number of columns. So we call it a square matrix. This is, we call it a square matrix. Okay. This one, they call it column matrix. Why? Because it has 4 rows by only 1 column. So they call it column matrix. Or they call it vector sometimes, if you use it in a vector space. But this one is 1 by 4. They call it, yes, row matrix. Row matrix. Okay. So this one 3 by 3, as we said, 4 by 1, this 1 by 4. Okay. Now, if the number of rows equal to the number of columns, we call it a square matrix. If you have only 1 column, they call it column matrix. If it has only 1 row, they call it a row matrix. Okay. Now, if we have this one, this is what? How many rows first? 3 by 4. Okay. This notation, we use it for the element in the row I and in the column J. Okay. So if I'm asking you to find A12, so I go for the first row and the second column. There is the first row, here is the second column, so this one is A12. A22, it means row number 2 and column number 2. Here is a row number 2, here is a column number 2, so it is 0. A32, it means you are in the row 3 and column number 2. So this is a 1. Now, can you find A14 and A24? Also A34? I will leave it for you. We have something called main diagonal. The main diagonal comes from the left corner here. Okay. This is what we call it the main diagonal, right? Okay. So if this element in the first row and first column, this is in the second row and second column. This is in the third row and third column. Okay. So this is A22, this is A11. This is the main diagonal. Where is the principal? Yeah, the principal diagonal comes from the left. A11, A22, A33, right? So the main diagonal has 1, 0, and 3. This is a zero matrix. They call it the zero matrix. All elements are 0, and also this is not a square matrix because it has 3 rows and 4 columns. So it is not a square one. Okay. Also, this one is a 0 matrix, but it is a column matrix at the same time, right? This is also 0 matrix, 2 by 2, so this is a square matrix, 0 square matrix. This is also 0 matrix, but it is a row matrix, right? This one and this one, they call it non-diagonal element equal to 0 is called diagonal matrix, right? It means you have only in the main diagonal an element non-zero, and the rest of the elements are 0. So we call it, yes, diagonal matrix. So it means all the elements in your main diagonal are elements different from 0, or maybe one of them may be 0, no problem, but not all of them are zeros. Okay, but the rest of the element in the matrix is 0. This is I1. It means a square matrix with 1 row and 1 column. This is identity matrix. They call it identity matrix. Identity matrix. So identity matrix, it means the main diagonal is 1 and the rest is 0. So it is a special case from the diagonal matrix. It is called identity matrix. The 0 matrix, it will be the identity for the addition, and the identity matrix will be the identity for the multiplication, as we will see later on. This is I3. It means identity matrix 3 by 3, and the main diagonal is 1, and the rest of the element are 0. This is, we call it the, maybe we have the elements are equal, okay, but not 1. So later on we will know how to get the constant as a common factor between columns and rows. Or this is exactly equal to A times 1, 0, 0, 0, 1, 0, 0, 0, 1. So when you multiply a matrix by a constant, you multiply every element in the matrix by this constant. Okay. This is how it works. Okay. This is B is exactly equal to 2 multiplied by the identity matrix 1, 0, 0, 0, 1, 0, and 0, 0, 1. Okay. Now, what does it mean transpose? It coming from trans. Trans, it means you are going to change something from H. If you have A equal to this one, so yes, I got the first row to be my first column, yes, and my second row to be my second column, okay? This is how to get the transpose of a matrix. So let's go for this one, yeah. So if I would like to have the transpose of this matrix, so you take the first row to be your first column, and the second row to be the second column. This is the transpose of this matrix. So if you have a matrix 2 by 3, its transpose will be 3 by 2, 3 rows and 2 columns. But before it was 2 rows and 3 columns. So the transpose, you change the rows into columns. Okay. How to find the transpose of this one? A transpose, I take the first row to make it my first column, and the second row to be my second column, and the third row to be my third column. Okay? Okay, let's go for this exercise. Is A a square matrix? Yes or no? What does it mean, square matrix? The number of columns is equal to the number of rows. Here, I have number of rows 2, but the number of columns 3. So, no, the answer is no. Is a row, it is a row matrix? No, it has 2 rows, so it is not a row matrix. Is A a column matrix? No, it has 3 columns. Given a matrix B, determined B, is B a diagonal matrix? Yes, the main diagonal here are non-zero and the rest is 0. Yes. Is B a scalar matrix? Yes. Okay, because this is a 1 is a constant here. Is B an identity matrix? Yes, because it has 1. Okay. Now, he's asking you to create 3 by 3 scalar matrix where all elements are equal to 7. 3 by 3, it means I have a matrix like this one. It has 3 rows and 3 columns. And all elements equal to what? 7, a scalar. Scalar, it means 7, 7, 7, 0, 0, 0, 0. Is it correct? Now, find the transpose of a 2 by 2 identity matrix. Identity matrix 2 by 2 is exactly 1, 0, 0, 1. If I would like to take the transpose, I make the first row as my first column, and the second row is my second column. So the transpose of I2 is exactly I2. So when you make a transpose for the identity matrix, you will have identity matrix from the same size. Okay? Find the transpose of the matrix, this one. To get the transpose of this one, it is 1 column, so it will be 1 row. This is how to get the transpose for this one. How to get the transpose for this one? It is one row, you just make it one column. 2 half 0 minus 3 over 2. Now, to get the transpose for this one, you take the first row to make it at the first column, second row as a second column, third row as a third column. Okay? Easy? Now, we are going to add two matrices and subtract two matrices first. To add, you should have the same size. So this is 2 by 3 matrix, 2 rows and 3 columns. This is also 2 by 3. So you can add them because in the addition, we are going to add the corresponding elements together, right? Exactly, I like put this one over this one and adding the corresponding number. So 2 plus 3, 5, minus 3 plus 1, minus 2, 0 plus 2 is 2, 1 minus 3, minus 2, 2 plus 2, 4, minus 5 plus 5 is 0. Okay, but here we said addition is not defined for matrices of different sizes because 2 by 3, this one, and this is 3 by 2. So we cannot add them. They should have the same size or the same dimension. Let's go for subtracting this one. This is 2 by 2, which is a square matrix. The number of rows equal to the number of columns. So we can subtract as we have done in the addition. We start from the left side. So 3 minus minus 2, it will be 3 plus 2, which is 5. Minus 2 minus 2 is minus 4. 5 minus 3, 2. 0 minus 4 minus 4. So to add or subtract, you should have the two matrices having the same size or same dimension. The multiplication is different. Why? To multiply by scalar, as we said last time, you have to add each one inside by this scalar. So minus 2 by 3, minus 6, minus 2 by minus 1, 2, minus 2 by 0, 0, minus 2 by minus 2, 4, minus 2 by 1, minus 2, minus 2 by 3, minus 6, minus 2 by 0, 0, minus 2 by minus 1, 2, minus 2 by minus 2, 4. This is how to multiply by scalar, only one number outside. But to multiply this one, yes, this is 1 by 3 matrix. This is 3 by 1 matrix. Yes, the number of columns from the left one equal to the number of rows in the right one. Okay, this is a condition for multiplying two matrices. Okay, let's go and multiply. Why we have this condition? Because exactly you take this one up here, okay, and you take the two, multiply the first one by the first one, the second one by the second one. So exactly you are doing 2 times minus 5 and plus minus 3 times 2 plus 0 times minus 2. Okay, and you get what? 2 minus times minus 5, minus 10, minus 3 times minus 6, and 0 times anything is 0. So you end up with minus 16. Remember, what do you have? This is what? This is 1 by 1 matrices. If you would like to write it as a matrices, it is exactly like this one. So this is 1 by 1. So when you multiply 1 by 3 by 3 by 1, it is exactly like cancel out this one. So you end up with 1 by 1 matrices. Okay. Can we multiply this one? Yes, because this is 1 by 4. And this is 4 by 1. So the number of columns to the left one equal to the number of rows of the right one. Exactly. You multiply the first one by the first one. So you minus 1 times 2. The second one by the second one plus 0. And you add this one by 3. And the third one by the third one plus 3 by 4. And the fourth one by the fourth one plus 2 by minus 1. So minus 1 times 2 is minus 2. 0 by 3 equal to 0. 3 by 4 equal to 12. 2 times minus 1 is minus 2. Okay, I have minus 4 plus 12. You end up with 8. If you would like to write it as a matrix, exactly like this one. So this is 1 by 4 multiplied by 4 by 1. As I said, exactly give you 1 by 1 matrix. If you are given A and B like this one, can we find A times B? A times B. A is 2 by 3. B is 3 by 2. So yes, this is 2 by 3 and this is 3 by 2. So you will get matrices C, say, exactly 2 by 2. This is what you should do now to get the C. Okay? Now, let's go and multiply 2, 3, minus 1, minus 2, 1, 2. And 1, 2, minus 1, 3, 0, 2. As we said, from the left-hand side, you take the row and come down to this column, and the first one multiply by the first one, plus the second by the second, plus the third by the third. If you would like to do it in one go, that's fine. 2 by 1 is 2, 3 times 2 is 6, so minus 1 times minus 1 plus, so you have 2 plus 6 plus 1 in the first one. And you take the row to the second column. So you multiply 2 by 3, 6, 3 by 0, 0, minus 1 by 2, minus 2. Once you finish with the first row from the left one, go and take the second row and do the same. Okay, so get minus 2 by 1, you have minus 2, 1 by 2, you have 2, 2 by minus 1 is minus 2. Now I finish with this one. I go for the second one. Do the same, the first one with the first one. So I have minus 6. 1 by 0, 0. 2 by 2, 4. So what do you have now? This is exactly this one, 9. This one, 4. This is this one with this one, so minus 2. And this is also minus 2. So yes, I was expecting to have 2 by 2 matrices. Okay. Let's go and do this one. He would like you to get A plus BT. So first, we write A, 2 minus 3, 5, plus B. What's B? 3 minus 2, 1. But B transpose. Okay? So I'm going to write this one again and then get the transpose of this one. So it is column matrix. It will be a row matrix, right? So 3 minus 2 and 1. And we are adding. So yes, which is fair enough, because this is becoming 1 by 3 and this is 1 by 3. So the condition of addition is already there. So the first one with the first one, so you have 5. The second with the second one, you have -5. The third with the third, you have 6. Okay. Now I will leave this one for you. How to multiply A by B? A is 2 minus 3, 5. B is 3 minus 2, 1. Yes, this is 1 by 3. This is 3 by 1. The condition of the multiplication is already here. The number of columns in the left one equal to the number of rows in the second one. How I can multiply? Yeah, I take rows and go to the column here. Even if I have 1, that's okay. So, and you add all the elements. 2 by 3, so you have 6. The second one by the second, you have plus 6 again, because minus 3 times minus 2 is 6. 5 times 1 is 5. So this one is 17. This is 1 by 1 matrix, because as I said, when you're multiplying, imagine you cancel out this one by this one. I will leave C, D for you. Here, first you multiply 2 times A. A is here. When I multiply it by 2, so it means I multiply each element here by 2. So I have 4 minus 6 and 10. Okay. Next, I would like to find CT. What is C? Here it is. To find the transpose, it means I make the first row as my first column. And my second row as my second column. Now, can I multiply? This one is 1 by 3. This one is 3 by 2. Yes, I can multiply, no problem with that. And what I get, I'm supposed to have 1 by 2 matrices. As we have done before, you take the rows from the left one and go to all the columns in it. I go with the first one. So multiply the first one by the first one, I have 12. The second one by the second one, and add it to this previous one. The third one with the third one. So I have 10 times 0 is 0. I finish with the first column. I go for the second column. I take this one with the second one. 4 times 2, it will be 8. So I will be in the second column because I'm multiplying by the second column here. Minus 6 by 1 by minus 1 plus 6. 10 times 3 is 30. Finish, close it. So 12 plus 6, 18. And here 14 and 30 is 44. So this one is, 1 by 2 matrix, which I was expecting to have here. Okay. A company with 2 different plans makes satellite radios and GPS units. The production costs for each item are given in the following matrices. So he gave you the cost here and the cost for the second one. So the first column representing the radio, the second one representing the GPS price. Okay. Find the matrix 1 over 5. So I have to add A plus B. Can I add A plus B? Yes, I can. 30 plus 36, 66. 25 plus 27, 52. 60 plus 54, 104. 114, sorry. 80 plus 74, 154. Now I can multiply the half inside, so it is exactly like dividing 62 by 2, dividing 52 by 2, and dividing 114 by 2, 154 by 2. This is how to multiply by scalar. 62 over 2 is 33. 52 over 2 is 26. 114 divided by 2 is 57. 154 by 2 is 77. Okay. So first you have to add and then multiply by the scalar. See you in the next video. Thank you.